Hello everyone, my name is Joshua Matheny. Today I will be talking to you about time value analysis and some healthcare formulas that time value analysis can assist you with in your career. Alright, so some key concepts we have are timelines, compounding, discounting opportunity cost, annuity, return on investment, net present value, internal rate of return, stated annual interest rates, periodic, and effective annual interest rates as well. Alright, so we're going to go ahead and dive into the introduction of time value analysis. Time value analysis is a very important healthcare finance technique used to determine the future valuation of investments. Decisions are made on investments using the time value analysis. That way they can ensure that they have a positive return on whatever they're spending their money on at the time, whether it be investments, equipment, securities, bonds, stocks. This could either be short-term or long-term, I'm sure, through the financial sheets that you've seen. The assets being short-term, being in the current, or long-term being in the non-current assets of the balance sheet. Alright, we're going to be talking about calculating compounding. Compounding is used to calculate the return on investment just of a one-time lump sum investment, generally subject to an interest rate over a fixed amount of time. So to the left here I have the formula: future value times the number of years equals the present value times 1 plus I. So to calculate this formula, you have to figure out which year you want to capture and to get the future value of your investment at that point in time. So the example I have here is, what is the future rate of $10,000 5 years in the future with an interest rate of 6%? So the goal here is to see what the $10,000 in 5 years from now accumulates. So to the right here, I've worked out the formula for you in 4 steps here. So you take 10,000, that's your present value. Then you have your future value with the 5 as n for the number of years. 1 plus the interest rate is 0.06. And as you start to calculate that, at the bottom here you get $13,400. So you've accumulated $3,400 total from interest after 5 years. That's pretty good. That's not too bad. Next up, we're going to be talking about calculating present value. We'll be using this discounting method and able to determine the present value of an investment that is due to receive in the future. The formula is similar to the future value formula, except for it's kind of reversed. So we have PV equals future value. Instead of multiply, this is going to be divide 1 plus n times the number of years here. So this is a way to kind of discount the future value and to see what the present value is here today. Usually discounting is used in measures of investments to determine the worth or the risk of the investment. We'll get on to that here in a slide or two. But the example I used here was just a basic one. You're going to receive $10,000 5 years into the future. The average annual interest rate is 5%, or that could be the discount rate. How much would that $10,000 be worth in the present? So we're trying to find out what the present day value of $10,000 would be 5 years from now. I know it's kind of a weird concept to grasp, but due to the inflation of money, we will find out through using the formula here at the bottom that actually $7,812 is going to be worth $10,000 here in the future. And this is just an example that's not accurate, I should say. But it's interesting to see how this formula here can give you an idea of how worth the investment is, or how opportunity arises, if you should wait or should you pull the trigger and use the money in a better spot. Alright, now we're going to be talking about annuities. Annuity is just a type of investment that requires a fixed payment on an annual basis, accruing some kind of interest rate. So the formula we have to determine the future value of an annuity is varied on what year you want to see the future value of. So if you go down here to the left for our formula, that formula needs to be applied to each year. I put a little graph at the bottom there. That's a timeline, one of our key concepts, just to kind of help display really what's going on here. So if you look to the right, the example, WVU Medicine deposits $500 at the end of each year for 4 years, paying 8% interest each compounded annually. What is the future value at year 4? So we're going to go to year 1, and you're going to see 629.85. So what's going on here is that's the first step of the equation, where you see 500 times 1.08 to the power of 3. Since that initial $500 investment is going to be accruing interest from the start of year 1 and then an additional 3 more years, that value at year 1 is just an overview of what your first $500 payment will accrue over the 4-year span. So you kind of zigzag back and forth to get the future values here. So to find the overall complete value, you'll go through and do the power of 3, the power of 2, and then plus 100, because your last annual payment at year 4 isn't subject to any interest accrued. So then after you have your timeline filled out, 1, 2, 3, and 4 of your annual payments and what they've accrued as far as interest, you can add up all those amounts to get $2,253, the total after 4 years. That's the future value of your investment, with a total of $253 accrued in interest over that time period. Alright, uneven cash flow streams. Uneven cash flow streams occur when a healthcare organization reports different cash flow each reporting year on a specific investment. Pretty self-explanatory. It's just when a healthcare organization spends money on an investment, they just want to make sure that the money generated, those uneven cash flow years, are going to be worth the investment. So what they'll do is they'll assign a discount rate. A discount rate is just an internal rate assigned just to represent the risk of that investment. The higher the discount rate, the riskier the investment's deemed. Discount rate is also used to measure the present value of the money generated within the cash flow years. We'll get into that within the next slide, but the overall objective is just to compare investments with similar risk to obtain the highest return. Alright, so now we're going to calculate the net present and future values of uneven cash flows. So this is just a visual representation of determining the present value of an uneven cash flow rate using the discounted rate. We're going to use 10% on telemetry pack investment by WVU Medicine. So each year from 0 to 4, you can see that $100 in cash flow year 1 generates $90. Cash flow 2 out of $200 generated is $165. Year 3, 250 generates 187, and then year 4, 400 generates 273. I just use this discounted rate to see the present value, and then they'll take those totals and see if they have a positive return, making any profit from this piece of equipment. And then to the right, not a lot talked about, not really commonly used, but this is just using the compounding rate on each cash flow year. The organization is going to see their cash flow and their discounted rates over the years to develop a return on investment plan. So the return on investment is a measurement used to describe the profit gain from the initial investment. Here I have dollar terms, and the next slide I will show you in the percentage terms. So here we have the Telepac costing the organization $500, and then by adding up the discounted rate throughout each cash flow year, we can determine that the total is $717.23. So then we'll subtract the initial investment of $500 for that piece of equipment, and we'll see that over 4 years, our profit is $217.23. So the percentage term is usually introduced as an internal rate of return. So calculated through our $500 Telepac at year 0, our $100 at year 0, and so on. At the bottom, you can see that we calculated the internal rate at 21.03. The 10% discounted rate is then subtracted to get an overall rate of 11.03 percentage points. These percentage points just make the expected return much higher than the other risk at a similar discounted rate. And the final time value analysis key topic that I want to talk to you about was the effective annual rate. So this is often referred to as the true cost rate. The effective annual rate is applied to any compounding interest that occurs more than just one period a year. So we have semi-annual, quarterly, periodic. Semi-annual is 2 periods, quarterly being 4, and periodic, it can be 12. It could just be measured in any other specified period under the contracts of the investment. So an example I used here is credit cards. They use APR to hide the true effective rate. They could advertise a 10% annual percentage rate, but actually charge 10.47% due to compounding each period over 12 months. So they actually do 1% a month, a little less than 1%, about 0.83% per month to get that 10% annual rate. But actually, since it's compounding over each period from month 1, 0.83, then 0.83, and eventually you'll get a little bit more than 0.83 versus the later months in that periodic year. So the formula is 1 plus interest times the month or the however many periods to the power of the periods minus 1.0. And this is how you'll see how credit cards can actually get away with advertising just a lower annual percentage rate and actually have a true cost of just a slightly higher version. And I don't know, it's a little scummy, but I feel like I should throw this in here, and this was a good example referenced by the book because it gave some real world experience. I'm sure everyone has a credit card, but I'm just astounded that I'm learning this now instead of any other process. I think it's just a really cool idea and good terms to go home with. And here are my references. I hope you enjoyed the slideshow. I hope you learned something from it. I certainly did, presenting this and doing my research on time value analysis, and I appreciate your time.